Welcome, happy learners. This is a video tutorial applying to section 1.1. In that video, you'll find an assignment, this one here that we're looking at. Let's do an example to help you work this assignment. Let's begin by going over to Desmos. You can find a link in the description. Clicking on that link, you should land on a page, something like this. What are we looking at? Well, we have graphed a function f here in black. It's a product of polynomial x and exponential e raised to the negative 0.5 times x. A portion of the graph has been indicated from 1 to 10. In other words, we've set a equal to 1 and b equal to 10. In this picture, we have c set equal to 0. Looking at the shaded portion, you can see that there looks to be 4 different boxes, and the heights of the boxes are given by the intersection of the box and the left portion of the box with the curve. In other words, left endpoints. If we change that value c from 0 to 0.5, we would be using midpoints. And then changing c from 0.5 to 1, we would end up with right endpoints. All right, so far so good. For c equaling 0, let's relate this to the assignment that we have. Here's the statement of the assignment. We've gone over what f would be. Here's the updated f for our example. We have that a would be 1, b would be 10, and so forth. Right. Now, let's take back a look here. That we're going to need to change our value of n between 10, 50, and 100. How do we do that in Desmos? If we scroll down, here we have box 1, box 2, box 3, box 4, and so forth. If we scroll down to box 9, indicates number of rectangles. The number of rectangles, n, is set equal to 4. The blue shaded portion, here, Desmos is calculating out in box 12, is this value. Capital I, this should look familiar. This is the Riemann sum. And it takes this approximate value. If we were to look under the curve would have this much area underneath it. Okay, what we want to do is we want to concentrate on the n value. So let's watch a little video. Here, n is equal to 6. And then if we watch n change, we see changes in the picture, and we see changes in the value of capital I, the Riemann sum. And eventually we're going to be interested in n equaling 100. Okay. Now, this value is done for right endpoints. We're going to do an example where we look at left endpoints. All right. So coming back, we have our Desmos, which is indicating an f, values for a and b, and then we want to use this particular function f, this particular interval, in our assignment. So I've updated the statement of the assignment to have f corresponding with Desmos and the interval corresponding with Desmos. I've gone ahead and I've done number 1 to determine delta x. We know that it's the length of the interval, b minus a, divided by n. 10 minus 1 is 9, we get 9 over n. Left endpoints, well, you start with the very first left endpoint, a, which is 1, and then you add, to move to successive left endpoints, you add delta x. And then that formula comes out to a plus I minus 1 times delta x. Okay, so the simple way to compute L sub n for n equal 10, 50, or 100, we've already looked. Desmos can do that for you. However, that's not very instructive. Let's get our hands dirty and actually compute these values with the aid of a spreadsheet. All right, So here's what we're after. We now want to use the computer, in other words, a spreadsheet, to compute L sub n for various values of n. I've opened up a spreadsheet. And then I fill out the spreadsheet by first hard coding in a value for A, a value for B. Let's start with, say, n being 50. And then I've left out the computation for delta x so that we can take a look at that. Now, these are hard values, 1, 10, and 50. Those are hard values that you just type in. But for delta x, let's use Excel to compute that. Well, we know what the formula is. It's b minus a over n. So we're going to simply type that in. Let's take a look. So up here we have our formula bar. In our formula bar, we're setting this cell, E, it's in column E, sub 2. We have column E, and then row 2. So E sub 2, and then we begin with an equal sign. You can see that up here in the formula bar. Equals, and then we do b minus a, note the parentheses. Well, where did we plug in our value for b? Our value for b is 10. Where does that occur? That occurs in column B, row 2, so we reference B2. And note that that has a blue box around it, and B2 is in blue colored font. So b minus a, well, our value for a we know is 1, whereas the 1 typed in cell B sub 1. Okay, so that's our numerator, and then divide by n. Very good. So if we hit enter, we should get Excel computing out 0.18. Nice. Next thing we want to do is we want to make a table. So here I've titled the columns. I want a column of i's, a column of xi's. So number, what box do I want to look at? The first box, the second box, and so forth. The xi's, those are the left endpoints for each subinterval. In other words, where does the subinterval begin? And then I want next the heights of each box, which is given by the function evaluated at the left endpoint. And then I want to compute the area of each box. Okay, so let's see how we can use certain functions of Excel to expediently do this. All right. And before we get into that, let's go back up here and let's look at n, change our value of n. Let's start first with n equaling 10, and note that delta x has been updated. Then come in and we want to list out 1 through 10. I've highlighted 2 cells and clicked and dragged, and then it propagates those values for me. For left endpoints, we start out with an equal sign to say that the formula is going to be, well, I know that I want to begin with A, which is in cell B1, and I need to introduce a $sign in front of the 1. And then the formula is A plus I minus 1. Well, the current value of I is given in A5. So I do I minus 1, and then multiply that difference by delta x. And then because my A value and my delta x value are static, the rows don't change. That's why I need to introduce the $signs. Right, so here I'm showing you that if we look at the formula for B5, that the B1 and E2 are the same as in the formula for B6. Whereas we want the I value given in the A column to change from A5 down to A6 down to A7 as we move our left endpoints. Okay, nice. And then we have that formula set, so we can simply click and drag. And the formula propagates nicely. To start a formula, we always begin with the equal sign. Here we're wanting to evaluate the function. What is the function? It's x times e. So x is the left endpoint, B5. The exponential, Excel knows it as exp. When we want to do a multiplication, we need to explicitly type in the asterisk to represent multiplication. So we have x times e raised to the negative 0.5, and then you have to do times the input. Good. So we have left endpoints, we have heights. Now we want to get areas of each box. What's the area of the first box? Type it in. What's the area of the second box? Type it in. And we want to use Excel to compute that for us. And note, since we want to take the height times the width is always given by cell E2, and therefore we need a $ in front of the 2. Excellent. We click and drag to propagate the formula, and here I'm just showing how we can check to make sure that delta x is always referenced in every row, whereas the height changes as we move from row to row. Okay, so this is all the prep work. Now we want to bring everything together. We know that we want to add up all of these values of the areas, the area of all the boxes. So right now I'm just labeling that this is going to be the left endpoint approximation, so L sub n. And then I'll just format that, put that in the center it, and then bold font it. And now to sum up, what do I want to sum? I want to sum all these values. Where do they occur? They occur in cell D5 down to D14. And the formula is equal sign, SUM for summing. And then you select that. There are parentheses to say where do you begin and where do you end. So D5 is where we begin and D14 is where we end. Match with the closing parentheses and then hit enter. And now we have the value for L sub 10. L sub 10. Okay, nice. Now, how would we produce L sub 50? L sub 50, right? Let's take a look at that next. Okay, so this is L sub 10, and that we've used 10 boxes, 10 left endpoints, 10 heights, each height times the width, and then sum up the areas. Right. Next, let's look at changing from 10, L sub 10, how do we update this spreadsheet to compute L sub 50? First thing that we note is that we only have 10 boxes represented, so we need to bring in 50 boxes. We need 50 rows. If we only highlight a single cell and drag, it's just propagating that single cell. If we highlight 2 cells and then click and drag, it will obtain the formula and propagate that formula. Now here, if we look, we start at A, and then we only go up to 2.62 as the last left endpoint. 2.62 is nowhere near 10, so we don't have to modify this formula at all. We can simply click and drag to propagate the formula out. Now there's a quicker way to propagate if we've already expanded cells in columns A and B. To expand cells in column C, we can simply bring our cursor to the last cell, the lower right corner, and if we shift click, and then while holding shift we click, it'll automatically propagate the entire column, and it knows where to stop because the adjacent column has been expanded. All right. Now, if we look at the cell is taking C14 times E2 E2 we know represents delta x, and we want that to remain static, so that's a good formula. We again shift and click to propagate for the remainder of that column. Right? Okay, so nothing really changed there. It's just a matter of bringing in more rows. The big thing that we want to notice is that in computing L50, we want to compute all 50 rows. So that means that our starting point, D5, is the same, but our ending point needs to be updated. So it has been updated from D14, which corresponds with the 10th box, to D54 to sum up all 50 areas. All right, nice. Now let's compare here our hard work done in Excel with the quick and dirty Desmos computation. Okay, so here's what we have for n equaling 50. We have that the sum of those 50 boxes is this value. And then in Desmos, for c equaling 0, meaning left endpoints, n equaling 50, we're getting the same numerical approximation. Good. So you want to be proficient in both Desmos and Excel. And the Excel is a little bit more work, but it gives you a better understanding of the fundamentals. Nice.